Hello everyone, my name is Jaindra Reddy, a CSC data science student at IRA Hyderabad. Now the topic is Gestalt's principles in multimodal data representation. So scientific data visualization typically relies on clearly identifiable imagery through unambiguous representations of data. Any interpretation of preprocessing is designed to extract and enhance patterns and structures in the data. In contrast, artistic projects that use data to control the generation and behavior of visual elements rely on the artist's vision to drive interpretation, structure, and mapping of the data to an image. The goals are not only to transmit information about the data, but also to use the data as a means for aesthetic exploration. Gestalt psychology describes the ways in which our perception groups and segregates elements in an effort to make sense of what we perceive. In the simplest sense, Gestalt theory describes how separate elements can be fused into a cognitive unit, and this idea can be used to events influence the design of the data visualization. Because these processes occur at a subconscious level, they always guide, to some extent, any creative and design decisions in both scientific and artistic visualization. By consciously using Gestalt theory to motivate the design process, we can somewhat bridge these two approaches and adjust visualization and sonication techniques to make the spectator a more active participant in the evaluation of data characteristics. In other words, by allowing the human cognitive system to pick up patterns and behaviors, we leverage one of the tasks at which it excels. This might make a visualization more ambiguous and open to interpretation, useful in a purely artistic context, but it can also assist data discovery and understanding as structures of data might be discovered by the spectator. In this article, we discuss the application of Gestalt theories to multimodal displays and present an application of these ideas in the visualization based artwork point cloud. Gestalt psychology and data visualization. Gestalt psychology, which has provided the foundation of the modern study of perception, proposes that the mind strives to grasp the big picture, a global whole. It does this through self organization tendencies simultaneously when the details are perceived. It constantly tries to extract patterns from a seemingly noisy, chaotic environment. This articulation might seem rather obvious, for we simply take for granted how our brains organize stimuli in the physical world. Still, the idea that the mind is able to construct narratives and patterns from a spatial distribution of a set of individual visual points is remarkable. Gestalt groups these in various principles that describe the effects of perception. These principles traverse other physiological capacities, working with one another to create an united perception. Artists have long explored, both consciously and unconsciously, the impact of Gestalt psychology principles and how they affect the perception of an artwork. Some artists who were deeply interested in Gestalt psychology, in particular those from the Bauhaus school of thought, include Laszlo Moholy, Nagy, Vasily Kandinsky, and Joseph Albers. The pertinent impact of this mode of thinking is clearly seen in their artwork. For example, Joseph Albers championed the idea of simultaneous contrast, which was also part of Carl Fried von Durkheim's discussions. In essence, he questioned the true appearance of color, for we never see hues or colors by themselves. Rather, we see them based on their contrast to other elements in the same composition. This is similar to the idea that a melodic line can be transposed into different keys, yet still retain its overall structure and convey the same abstract forms and attributes. Multimodality and data visualization techniques are excellent at reducing n-dimensional data sets into a more digestible representation, enabling us to dissect the gist of a verbatim. However, human perception is much more complex in passing information. Our input sensors work in tandem with each other to give us a concise analysis of the surrounding. It is well known that information from one sense can alter the way events from another are perceived. In particular, multimodality between sight and hearing can affect the perception and judgment of simultaneity and casuality. It can also affect the subjective perception of quality and other aesthetic judgments. Therefore, sonification can significantly affect the perception and judgment of a visualization. These are interactions and relationships between sound elements that allow us to segregate or fuse elements, analogous to visual separation and growing up and grouping. Although these auditory interactions were not expressly codified or in Gestalt theory, they seem to fit well with it and pursue the Gestalt principle of wholeness. Multimodal data representations, such as combining sonification and visualization of data, can become more effective and clear if these Gestalt principles are applied comprehensively. For example, auditory scene analysis is a model for studying how the human auditory system organizes organizes sounds into groups of coherent patterns that relates to the principles of perceptual organization explored by the school of Gestalt psychology. Gestalt as a data visualization strategy. Gestalt theory has been discussed previously as part of data visualization strategies. Particularly in high dimensional data projection, there is awareness in the data visualization community of the need to incorporate perceptual and cognitive elements in the design of the data visualizations to ensure that important features in the data are not obscured or confused with others. Additionally, awareness of Gestalt theories and impact of multimodal stimuli on perception can inform can inform decisions during the process of construction with data visualization and sonification to enhance both its technical and aesthetic aspects. The Gestalt laws that we discuss here pertain to the ability of a specific stimuli to be perceived multimodally. A homogeneous visual composition creates a mundane space and where the perception of depth is unresolved, leading to complications in grouping objects. Without a consistent internal organization, a visual construct is perceived as lacking stratification, resulting in the inability to partition the foreground and the background. As a system of field organization is introduced, a figure would be perceived to possess an object-like character, while the background has less perceptual saliency. This leads to the tendency to perceive the ground as a mere platform for the figure to be projected onto, and the borders between the two to belong to the figure, rather than a separation between the two. Apart from Edgar Rubin's famous faces face drawing, this principle has been explored in various artistic fields. Two-dimensional compositions in art and graphic design use this relationship as a fundamental visual tool to create stratification and grouping of elements. Negative and white spaces are also concrete examples of how this technique is widely used. For example, in the realm of typography, in Japanese culture, the concept of space or intervals known as is integral as a structure element that binds the form and the surrounding. Compositions in the auditory domain also adhere to such principles. For example, the temporal hierarchy of structure in music compositions and the management of the structures is thoroughly dissected in microsound. In aesthetic explorations, these relationships help delineate the boundaries between an entity and emptiness. Emptiness, after all, defines the boundary and things. By exploiting patterns or colors that encourage or discourage these relationships, the design of a visualization can point the viewer towards specific structures or groups. Proximity and similarity. Assuming that the ground is a static surface, we are now able to separate the figure from the ground. What needs to follow in this is the grouping of elements as a function of distance between them. Gestalt theory states that the integration of individual components into a whole can be achieved through the use of proximity principle. Perception tends to group stimuli that are close together as part of the same object. This principle complements the principle of similarity, which states that Elements also tend to be integrated into groups if they are similar to each other. Although these two principles work hand in hand and can strengthen the organization of elements. They can also be varied independently to investigate their joint effects on perceived grouping. Interestingly, a new style of painting, pointillism, started to emerge around the same time Gestalt psychology started to take shape. Pointillism relies on the brain's ability to construct forms from disconnected points, even in the absence of clear, definite borders and shapes. By manipulating density, size, the use of color, or various other qualities, one is able to influence the viewer towards the segregation of certain elements in the composition of such as shapes and objects. This proximity principle can be exploited in data visualization to encourage perceptual grouping and clustering. The principle of closure. Human beings are symbolic animals, confronted with a trace that they will seek to interpret it to give it meaning. This is precisely how the principle of closure works. Literally speaking, it's about drawing conclusions. When we are presented with an incomplete stimuli, our brain tends to make sense of it, and by making assumptions, we are applying the principle of closure to our perception. By internally breaking up with figures and perceptually subdividing a stimuli into multiple individual parts, it is possible to reverse engineer this effect and cause the disintegration of the whole. This is similar to the camouflage effect used by certain animals in their struggle for survival. Generally speaking, we are extremely competent at figuring out the bigger picture so long as there is enough information for the principle of closure to take effect. An excellent visual example of this principle could be found in the works of Oscar Munoz. In his series of works, Retrato, Munoz explores the boundaries of form and the dissipation of form by painting on a hot stone. As new lines are drawn, the previous sections of the painting evaporate. However, although the painting is incomplete, our minds have to draw conclusions and see the full image as though it was still there. The impermanent nature and perception can also be seen in the traditional practice of diosym water calligraphy application. Following these ideas, an artistic explanation called point cloud was developed. This artwork presents the data of lightning occurrences around the world via visual and auditory stimuli. Pointillism and granular synthesis were chosen as the two techniques for visualization and solidification because they exploit Gestalt theories of pattern organization and shape discrimination. Both of these techniques rely on some sort of perceptual diffusion to achieve a large image made up of a microscopic structure. The identity of the microelements is not perceived, but their composition defines the macrostructure. Multimodality in data presentation is explored as part of the artwork by carefully tuning the excitation for each sense, sight and hearing, to exploit the discussed Gestalt's principles. Multimodal principle of past experience. As discussed in previous sections, Gestalt theory functions for various senses and it can be used together to strengthen perceptual attributes. With point cloud, we can explore past experience as a multimodal principle and how two senses merge separate stimuli into a single event. When the auditory perception is fed with a familiar stimulus, it tends to bias the whole perceptual image to the direction that is of known origins. Although this principle seems less important than the other principles of Gestalt psychology, it plays an extremely important role in our exploration. In this case, the modeling of thunder sounds elicits that particular phenomena, which then serves as an accompaniment to the visualization. Neither the visual nor auditory stimulus could function by themselves to provide the context of the whole or would suffice as a means to provide the full information. However, when fused together, they form a more concise overall representation of the dataset. So here are the images. Figure 1. Still image from point cloud. Visualization of lightning occurrences over the course of a single year. Day 333. Second figure is Gestalt laws of grouping. A. Similarity, proximity, and closure. And figure 3 is about NASA Marshall Space Flight Center dataset. Lightning occurrences for flattened 720 into 360 bins. Data points over a series of dates. So figure 4 is categorization of forms over time. As the viewer's mind slowly grasps the bigger picture via categorization of forms, the shape of land masses becomes decipherable. Figure 5. Hidden structures. Top. Probability distribution for each data point. Bottom. Direct mapping of each data point. Figure 6. Point cloud sonification. Varying density of three granular streams mapped to flash rate. Thank you.